Today we are going to discuss about differential and difference equation representation of LTI systems. Linear constant coefficient difference and differential equations provide another representation for the input-output characteristics of LTI systems. Difference equations are used to represent the discrete time systems, while differential equation represents continuous time systems. A second order difference equation is y of n plus y of n minus 1 plus 1 by 4 into y of n minus 2 is equal to x of n plus 2 into x of n minus 1. In the above example, order is n because the difference equation involves y of n minus 2, implying that a maximum memory in the system output of 2. In general, nth order linear constant coefficient difference equation is given by summation k is equal to 0 to n ak into y of n minus k is equal to summation k is equal to 0 to m bk into x of n minus k. This equation can be rearranged in the form y of n is equal to 1 by a naught summation k is equal to 0 to m bk into x of n minus k minus summation k is equal to 1 to n ak into y of n minus k. This equation directly expresses the output at time n in terms of the past values of input and output. An equation of the above form is called a recursive equation since it specifies a recursive procedure for determining the output in terms of the input and previous output. An equation of the above form is called a recursive equation since it specifies a recursive procedure for determining the output in terms of the input and previous output. When n is equal to 0, the above equation reduces to the form y of n is equal to 1 by a naught summation k is equal to 0 to m bk into x of n minus k. Here y of n is an explicit function of the present and previous values of the input. For this reason, it is often called a non-recursive equation since we do not recursively use previously computed values of the output to compute the present value of the output. Next, we are going to discuss about block diagram representation. A block diagram is an interconnection of elementary operations that act on the input signal. It provides a pictorial representation which can add to our understanding of the behavior and properties of these systems. It can be considerable value for the implementation or simulation of system. Block diagram representation consists of an interconnection of three elementary operations on signals. First one is scalar multiplication, that is y of t is equal to c into x of t, or y of n is equal to c into x of n, where c is a scalar. Second one is addition, that is y of t is equal to x of t plus w of t, or y of n is equal to x of n plus w of n. Next is integration for continuous time systems. Y of t is equal to integration minus infinity to t x of tau into d tau, or a time shift for discrete time systems y of n is equal to x of n minus 1. Then for discrete time systems, for example, consider a causal system described by the first order difference equation y of n plus a into y of n minus 1, which is equal to b into x of n. Then the block diagram representation as shown in the figure, x of n is the input that should be multiplied with b, and we have to represent y of n and y of n minus 1, and that y of n minus 1 should be multiplied with a, then we have to add. That means we have to write one summation and we have to add y of n and a into y of n minus 1. There are two ways by which difference equation can be represented in the block diagram forms. They are, first one is direct form 1, second one is direct form 2. For example, draw the direct form 1 and direct form 2 implementation for the following difference equation. Y of n plus 1 by 4 into y of n minus 1 minus 1 by 8 y of n minus 2 is equal to x of n plus x of n minus 1. So we need to rearrange the given equation such that it should contain y of n terms in the left hand side and remaining terms in the right hand side. After rearranging, we get y of n is equal to x of n plus x of n minus 1 minus 1 by 4 y of n minus 1 plus 1 by 8 y of n minus 2. Then the direct form representation, direct form 1 representation of the given equation is x of n and x of n minus 1 we have to add, and y of n minus 1 and y of n minus 2. In this case, y of n minus 1 should be multiplied with 1 by 4 and y of n minus 2 should be multiplied with 1 by 8. Then we have to add y of n minus 1 and y of n minus 2. So y of n terms should be in the right side, x of n term should be in the left hand side. Next is direct form 2. Since LTI systems are considered, we may interchange their order without changing the input-output behavior of the cascade. Then f of n is equal to minus 1 by 4 f of n minus 1 plus 1 by 8 f of n minus 2 plus x of n. The output of the second system y of n is y of n is equal to f of n plus f of n minus 1. So the block diagram representation of the given equation as shown in the below diagram. So we are going to write in terms of f, hence it is f of n minus 1 and f of n minus 2. F of n minus 1 should be multiplied with 1 by 4, f of n minus 2 should be multiplied with 1 by 8. Then we have to add the signal in the direct form 2, hence in direct form 2 block diagram representation, memory elements usage is less. For continuous time systems, consider the causal continuous time systems described by first order differential equation dy of t divided by dt plus a into y of t is equal to b into x of t. Then after rearranging the given equation, we get y of t is equal to 1 by a into dy of t divided by dt plus b by a into x of t. Since differentiators are both difficult to implement and extremely sensitive to errors and noise, differentiators are not used. Then dy of t divided by dt is equal to b into x of t minus a into y of t. Integrating between the limits minus infinity to t, then y of t is equal to integration of minus infinity to t magnitude of b into x of tau minus a into y of tau into d tau. Hence, integrators are used in block diagram representation. It represents the memory storage element of the system. For example, one block diagram representation for the above equation is given. So here we have used integrator as memory storage element. X of t should be multiplied with b. Then y of t is multiplied with minus a. Then we have to add a x of t and y of t. There are two ways by which differential equation can be represented in the block diagram forms. They are direct form 1 and direct form 2. For example, draw the direct form 1 and direct form 2 implementation for the following differential equation. The given equation is d square y of t divided by dt square plus 5 into dy of t divided by dt plus 4 into y of t is equal to d by dt of x of t. After rearranging the above given equation, we get d square y of t divided by dt square is equal to dx of t divided by dt minus 5 into dy of t divided by dt minus 4 into y of t. On integrating the above equation, we get dy of t divided by dt is equal to x of t minus 5y into t minus 4 into integration of y of t into dt. Once again, integrating above equation, we get y of t is equal to integration of x of t into dt minus 5 into integration of y of t into dt minus 4 into double integration of y of t into dt. Block diagram representation for the given equation as shown in the figure. Then direct form 2 representation of the given equation is f of t is equal to x of t minus 5 into integration of f of t into dt minus 4 into double integration of f of t into dt. And y of t is equal to integration of f of t into dt. The block diagram representation of the given equation in direct form 2 as shown in the figure. Next, we are going to discuss about solution of difference and differential equations. The output of a system described by a differential or difference equation can be expressed as a sum of two components associated only with initial conditions, natural response and denoted as y of n, associated only to the input, that is forced response and denoted as y of f. The natural response is the system output for zero input, that is called as zero input response or ZIR, while the forced response is the system output assuming zero initial conditions, zero state response or ZSR. Then we are going to discuss about natural response. The natural response is the output when the input is 0. That is summation k is equal to 0 to n ak differentiation of y of n into y of t divided by dt of k is equal to 0. The natural response for a continuous time system is of the form y n of t is equal to summation I is equal to 1 to n ci into e power r I into t, where Ri are the n roots of system's characteristic equation. Summation k is equal to 0 to n ak into r to the power k is equal to 0. In discrete time, the natural response y of n is the solution to the homogeneous equation summation k is equal to 0 to n ak into y of n into n minus k is equal to 0, where Ri are the n roots of discrete time systems characteristics equation, that is summation k is equal to 0 to n ak into r of n minus k is equal to 0. For example, find the natural response of the homogeneous equation. Y of n is y of n minus 9 by 16, y of n minus 2 is equal to x of n minus 1, with the initial conditions are given. Y of minus 1 is equal to minus 4 by 3 and y of minus 2 is equal to 16 by 3. For zero input response, y of n minus 9 by 16 into y of n minus 2 is equal to 0. The zero input response, so I have to take it as 0 in the right side. Taking y of n outside, I will get 1 minus 9 by 16 s to the power minus 2 is equal to 0. So finding the roots, we get s is equal to plus 3 by 4 or minus 3 by 4, or we can write it as s is equal to plus or minus 3 by 4. Then we have to find the natural response of the system. Then y of n is equal to C1 into 3 by 4 to the power n plus C2 into minus 3 by 4 to the power n, where plus 3 by 4 and minus 3 by 4 are the roots. Then applying the initial conditions, y of minus 1 is equal to minus 4 by 3. It is given, hence y of minus 1 is equal to minus 4 by 3, which is equal to C1 into 3 by 4 to the power minus 1, because n value is minus 1, plus C2 into minus 3 by 4 to the power minus 1, which is equal to minus 4 by 3 is equal to C1 into 3 by 4 inverse is 4 by 3 minus C2 into once again 4 by 3. Call it as equation number 1. Next condition is given, y of minus 2 is equal to 16 by 3, which is equal to C1 into 3 by 4 to the power minus 2 plus C2 into minus 3 by 4 to the power minus 2, which is equal to 16 by 3 is equal to C1 into 4 by 3 square plus C2 into 4 by 3 square, which is equal to 16 by 3, which is equal to C1 into 16 by 9 plus C2 into 16 by 9 square. Call it as equation number 2. Then solving equation number 1 and 2, we get C1 is equal to 1 and C2 is equal to 2. Then the natural response is y of n is equal to 3 by 4 to the power n plus 2 into minus 3 by 4 to the power n for n greater than or equal to minus 2. That means C1 value is 1, C2 value is 2. Next problem, find the natural response for the system d square y of t divided by dt square plus 5 into dy of t divided by dt plus 6 into y of t is equal to 2 into x of t plus dx of t divided by dt with initial conditions y of 0 is equal to 3 dy by dt at t is equal to 0, the value is minus 7. For 0 input response, right hand side equation we have to take it as 0. Then y double dash of t plus 5 into y dash of t plus 6 into y of t is equal to 0. Or if I take y of t outside, then inside the equation t is p square plus 5p plus 6 is equal to 0. After finding the roots, we get p is equal to minus 2 and p is equal to minus 3. Now we have to find the natural response of the system. Then y of t is equal to c1 into e power minus 2t plus c2 into e power minus 3t, where minus 2 and minus 3 are the roots of the system. Then y of 0 initial conditions are given equal to 3. Applying to the above equation, I will get C1 plus C2 because e power 0 and e power 0 becomes 1. Remaining terms are C1 and C2. dy by dt at t is equal to 0. After differentiating, we will get minus 7 is given value equal to minus 2C1 minus 3C2. Call it as equation number 2. Solving equation number 1 and 2, we get C1 is equal to minus 1 and C2 is equal to 1. Then natural response of the system y of t is equal to minus 1 into e power minus 2t plus e into e power minus 3t. Next, we are going to discuss about forced response. The forced response is the solution to differential or difference equation for a given input assuming the initial conditions as 0. It consists of two components. First one is a term of the same form as the natural response. Second one is a particular solution. The particular solution is denoted as yp of n or yp of t. Yp of n for discrete time system and yp of t for continuous time system. It is usually obtained by assuming the system output has the same general form as the input. Next, we are going to discuss about how to find the forced response. So, procedure to find forced response. Find the form of the natural response y of n from the roots of the characteristic equation. Find a particular solution y of p by assuming it is of the same form as the input at independent of all terms in the natural response. Determine the coefficient in the natural response so that the forced response y of f is equal to y of p plus y of n has 0 initial condition at t is equal to 0 or n is equal to 0. The forced response is valid for t greater than or equal to 0 or n greater than or equal to 0. For example, find the forced response of the system described by the difference equation y of n is minus 1 by 4 y of n minus 2 is equal to 2 into x of n plus x of n minus 1 has input signal x of n is equal to u of n We have to find the natural response. Y of n minus 1 by 4 into y of n minus 2 is equal to 0, that is ZIR. Then y of n into 1 minus 1 by 4 to the power s minus 2 is equal to 0, which is equal to 1 minus 1 by 4 to the power s minus 2 is equal to 0. Then s1 is equal to 1 by 2 and s2 is equal to minus 1 by 2. Then natural response y of n is equal to c1 into half to the power n plus c2 into minus half to the power n. To find the particular solution, y of n minus 1 by 4 y of n minus 2 is equal to 2 into y of n plus y of n minus 1. Because x of n is given as y of n. So we have to replace 2 into x of n by 2 into y of n, and we have to replace x of n minus 1 by y of n minus 1. Let yp of n is equal to k into y of n. Then k into y of n minus 1 by 4 into k into y of n minus 2 is equal to 2 into y of n plus y of n minus 1. For n greater than or equal to 2, the equation becomes k minus 1 by 4 into k equal to 2 plus 1, which is equal to 3. Then k is equal to, we get the answer as 4. Therefore, yp of n is equal to 4 into u of n. Therefore, forced response y of n is equal to c1 into half to the power n plus c2 into minus half to the power n plus 4 into u of n. Call it as equation number 2. To find the forced response, all initial conditions are set to 0. Then forced response y of n minus 1 by 4 y of n minus 2 is equal to 2 into y of n plus y of n minus 1. Call it as equation number 3. From equation number 3, y of 0 is equal to 2, y of 1 is equal to 2 plus 1, which is equal to 3. Substituting these values in equation number 2, we get y of 0 is equal to 2, which is equal to c1 into half to the power 0 plus c2 into minus half to the power 0 plus 4 into u of 0, which is equal to c1 plus c2 plus 4, or c1 plus c2 is equal to minus 2. Call it as equation number 4. Then y of 1 is equal to 3, which is equal to c1 into half to the power 1 plus c2 into minus half to the power 1 plus 4 into u of 1, which is equal to c1 by 2 minus c2 by 2 plus 4, or c1 minus c2 is equal to 2. Call it as equation number 5. Then y of n is equal to minus 2 into minus half to the power n plus 4 into u of n. Determine the forced response for the system described below. D square y of t divided by dt square plus 5 into dy of t divided by dt plus 6 into y of t is equal to x of t, where x of t is equal to e power minus t into u of t. Therefore, d square y of t divided by dt square plus 5 into dy of t divided by dt plus 6 into y of t is equal to e power minus t into ut, because the value given x of t is equal to e power minus t into ut. Call it as equation number 1. To find the natural response, y double dash of t plus 5 into y dash of t plus 6 into y of t is equal to 0. Then if we take y of t outside, p square plus 5p plus x is equal to 0. Finding the roots, we get p as minus 2 and minus 3. Then y of t is equal to c1 into e power minus 2t plus c2 into e power minus 3t. The particular solution is given by yp of t is equal to k into e power minus t into u of t, or dy of t divided by dt is equal to minus k into e power minus t into ut. Then d square yp of t divided by dt is equal to k into e power minus t into ut. Substituting these values in equation number 1, we get k into e power minus t ut minus 5k into e power minus t into u of t plus 6k into e power minus t into u of t is equal to e power minus t into u of t. That is k minus 5k plus 6k is equal to 1, or k is equal to half. Therefore, yp of t is equal to half into e power minus t into u of t. The forced response is given by y f of t is equal to c1 into e power minus 2t plus c2 into e power minus 3t plus half into e power minus t into u of t. Then y f of 0 is equal to 0, which is equal to c1 plus c2 plus half. Call it as equation number 2. Then dy of t divided by dt is equal to minus 2c1 e power minus 2t minus 3c2 e power minus 3t minus half into e power minus t. Then dy of t divided by dt is equal to 0, which is equal to minus 2c1 minus 3c2 minus half. Call it as equation number 3. Solving equation number 2 and 3, we get c1 is equal to minus 1, c2 is equal to half. Then y f of t is equal to minus 1 into e power minus 2t plus half into e power minus 3t plus half into e power minus t into u of t. The total response of the system is the sum of natural and forced response of the system.